You check the weather forecast to see if you need a jacket, right? But what if you could use that same forecast to predict the outcome of a soccer match? It sounds a little out there, I know, but it's a fascinating question. And today, we're going to dive into some incredible research that put that exact idea to the test. So, to understand why anyone would even bother trying, you really just have to follow the money. The global sports betting industry is valued at up to $1 trillion a year. That's a staggering number. And get this, 70% of that, we're talking $700 billion, is bet on soccer alone. So you can see why the hunt for even the tiniest predictive edge is absolutely massive. And that's the ultimate challenge, isn't it? Soccer is a game of skill, sure, but it's also about passion. And sometimes just pure dumb luck. A lucky bounce off the post, a moment of individual brilliance, a controversial call from the ref. That chaos is what makes the game so exciting. So the idea of finding a reliable pattern in all of that, well, it seems almost impossible. Okay, so here's our game plan for today. We'll start by looking at this billion-dollar guess. Then we'll get into the core idea, the weather hypothesis. After that, we'll see how they trained a digital referee to find patterns, check the final score to see if it worked, and finally put it all to the ultimate test, weather versus the bookies. Look, trying to predict soccer outcomes is nothing new. Most models look at all the usual suspects, right? A team's recent form, how they've played against this opponent in the past, player injuries, home field advantage. But the problem is everyone is using that same data. So it's incredibly hard to get a real advantage. This study started by asking, what if there's a missing piece of the puzzle that almost everyone is ignoring? And the funny thing is, the idea for this research didn't come from some huge data corporation or a betting syndicate. Nope. It all started with a simple conversation between a student, Denny Asarius Palingui, and his supervisor. They just got to talking and wondered, since soccer is played outdoors, exposed to the elements, what if a critical overlooked factor was literally in the air? What if the key was the weather? So they built this entire research project on two very simple, almost common sense ideas about how weather could physically affect a soccer match. Okay, so the hypothesis basically boils down to this. First, the temperature gap. The idea is that if there's a big temperature difference, we're talking more than 5 degrees Celsius between an away team's hometown and the city they're playing in, they'll struggle to adapt physically. That should give the home team an edge. Second, heavy rain. If it's raining hard, more than 5 millimeters, the ball gets slick, the pitch gets waterlogged, and it just becomes harder to control everything. That should lead to sloppier play and ultimately fewer goals. Make sense, right? So how in the world do you test something like this? Well, they didn't just guess or look at a few games. They used machine learning. And you can kind of think of it as training a digital referee to watch thousands of games at once and spot patterns that a human eye might completely miss. So when we say machine learning, what are we really talking about? In simple terms, it's about feeding a computer a massive amount of data. In this case, years and years of soccer results, plus the specific weather conditions for every single game. Then you basically tell the computer, go find the important connections on your own. You don't tell it the rules, you let it discover them. The process they followed was super methodical. First, they gathered 4 whole seasons of match data from Spain's top leagues, along with all the weather data. Then, they zeroed in on just 2 things, those temperature gaps and the rainfall amounts. And here's the cool part. They trained 3 different machine learning models to compete against each other. Think of it like hiring 3 different types of detectives. One looks at similar past cases, another draws complex lines to separate the clues, and the third one creates a whole committee to vote on the outcome. All right, this is it, the moment of truth. After all that data crunching and all that training, we get to the big question. Did adding weather data actually create a better prediction model? Did the hypothesis actually hold up? So of those 3 different digital referees they put to the test, which one turned out to be the star player? Which one proved to be the most valuable predictor? Well, for predicting the final result, a home win, an away win, or a draw, in games with that big temperature gap, the SVM model was the clear winner. It correctly predicted the outcome nearly half the time at 49.51%. Now, I know what you might be thinking. That's less than a coin flip. But hang on. With 3 possible outcomes, just guessing gets you to 33%. So jumping all the way to almost 50% is a huge statistical improvement. And you know what? The results for the rain hypothesis were even stronger. When it came to predicting if a match with heavy rain would have more or fewer than 2.5 goals, that same SVM model was correct an impressive 56% of the time. This showed a really clear, predictable link between a downpour and a low-scoring game.
Okay, so the model clearly found something significant. That's cool on its own. But here's the real test. How does its performance stack up against the real-world experts, the bookmakers who set the odds for that trillion-dollar industry? And this is where it gets really, really interesting. For predicting the final result, okay, the bookies are still a little bit better, hitting around 54% accuracy. But look at the over-under market for rainy games. The model actually outperformed the bookmakers' average, hitting 56% accuracy against their 55%. This is a huge deal. It suggests the model found a true inefficiency, that even the pros might be systematically underestimating just how much a slippery pitch can disrupt a game. So what's the bottom line here? It's not about having a perfect crystal ball that can predict every single match. Of course not. It's proof that a small, often overlooked detail, something as simple as the weather, can have a real, measurable, and predictable impact on something as complex and chaotic as a professional soccer game. And that just leaves us with a fascinating final thought. If something as mundane as the weather holds a hidden key to prediction, what else are we overlooking? In sports, in finance, maybe even in our own daily lives, what is the next hidden variable out there, just waiting to be discovered, that could completely change the game?